Okay. Okay, let me admit some couple of people here. Okay. Okay. So deep computer vision using CNN, which is convolutional neural network. Okay. So let's see. First, let's see the context. Okay. So IBM Deep Blue, right, 1996. Okay. So it was a historic moment when Deep Blue, IBM Deep Blue computer, which is supercomputer, right? It beat Gary Kasparov. Gary Kasparov, he was the world champion at that time, right? So chess champion, right? World chess champion. And then he was beaten by Deep Blue, which hadn't occurred before that. It was a revolutionary moment. Means a machine beat a human in chess. In chess, this might say Gary Kasparov. He was one of the was all-time strongest player. Okay? This is the player like you're a machine level idea, right? And it was momentous. Right? I remember back then it was headline news. Right? So I mean, okay, so you know, so okay. It wasn't until fairly recently that computers were able to reliably perform seemingly trivial tasks. Yes, I mean, it was, 1996 Deep Blue computer beat the human, but still, even today, machines cannot do things that we take for granted, right? So still, there is still, a way to go, right? Okay, so okay, so let's talk about convolutional neural network emerged from the study of the brain's visual cortex. So as I said before, right? So this is, this deep learning, deep learning neural network server. It's loosely modeled after the brain. I mean, how the brain works. I have a brain so this school, it's loosely modeled after that, right? So I mean, people studied, scientists, they studied how the brain, how our vision system works, right? Our vision कसरी काम गर्छ भन्दाखेरि त्यो उनीहरूले रिसर्च गरे त्यो त्यसैबाट इन्स्पायर भएर CNN, which is convolutional neural network, right? So okay. So emerged from the study of the brain's visual cortex, and they have been used in image recognition since the 1980s. Okay, so it's still the dominant, it's the go-to method for go-to algorithm for computer vision. This image recognition this guy is still the go-to method, CNN still, which came about in 1980s by Yann LeCun and his team. Yann LeCun, he's the he's the chief of AI, right? Yeah, AI division chief at Meta, right? Facebook's parent company, Facebook name, this go AI research go lead गर्ने चाहिँ Yann LeCunले it's been about 10 years, I think. He's leading that team, and he's also a professor at New York University, right? NYU, is a professor, right? And yeah, so let's see what that is. What is CNN? Right? So let's see. So first we need to know the architecture of the visual cortex. We have visual between brain and how do we see, right? Or how do we, how our vision system works? Okay, so so David H. Huville and Torsten Weisel performed a series of experiments on cats. See, they studied cat brains, 1958, 1959, and a few years later on monkey. So, and then that gave crucial insights into the structure of the visual cortex. I mean, the biological brain is more or less, be it cat or a human, or a monkey. They are pretty much the same structure, same architecture at least. And then, of course, human brains are more complex, more it's more capable, of course. Okay, so they showed that many neurons, there are of course neurons, many neurons in the visual cortex have something called local receptive field. Local receptive field, but a small local receptive field, so meaning that they react only to visual stimuli. Okay, located in a limited region of the visual field. Okay, I'll explain what that is. Okay, in which local receptor fields of 5 neurons are represented by dash circle. Okay, so so for example, look over here. If you look over here, यसमा चाहिँ तपाईँको यो सानो सानो सर्कल देखिन्छ नि. Okay, so those are, so हामीले देख्ने बित्तिकै हामीले कुनै पनि इमेज केही पनि हामीले जस्तो अहिले देखिरहेको छौँ नि, त्यो भनेको ट्याक्क सबै पुरै एकैचोटि देखेको चाहिँ होइन है. त्यो के भन्दाखेरि it's there are small regions, right? Regions of space, है. अनि त्यो चाहिँ के गर्छ भन्दाखेरि अनि त्यो त्यो धेरै हुन्छ, धेरै, अनि त्यो जोडेर चाहिँ है, अनि त्यहाँ चाहिँ layer by layer हुन्छ, layer by layer, है. So let me quickly try to explain what that is, है. Okay, so यहाँनिर देख्नुहुन्छ. So for example, if you're looking at this picture of a house, है, okay, or house itself, है, त्यस्तो छ भने now these are the we have this small visual receptor field. Right? We have this small visual these like this one, right? That one, right? These are small visual receptor field. And usually they pick out, say and then there are layers. They smell layer 1, layer 2, layer 3 one. Right? There are 3 layers, and the first layer. Okay. Now what happens is light, after reflecting from the this picture, okay, it goes through our eye, and eye retina ma jन्छ, and retina ले के गर्छ हैन, there it's the light this one त्यहाँ चाहिँ पर्दा जस्तो हुन्छ जहाँ कि they are light sensitive some kind हैन, त्यो त्यसले चाहिँ एउटा पर्दा हुन्छ जुन चाहिँ light sensitive है, अनि त्यो अनुसार चाहिँ त्यो electric signal मा convert हुन्छ, and they will be sent to the brain. So this is the brain part, right? Yes, the brain part. And the brain part मा गएपछि के हुन्छ भन्दाखेरि there are several layers, right? Layers हुन्छ visual cortex मा, यो चाहिँ visual cortex हो है. So visual cortex is part of our brain, right? Visual cortex is part of our brain. The brain मा layers, right? First layer के गर्छ भन्दाखेरि they pick out, means they pick out this very very rudimentary, very the fundamental shapes are जस्तै your arc, right? Horizontal line, slightly slanted line, right? A vertical line, and so on, right? So यस्तो है, हरेक receptive field ले के गर्छ भन्दाखेरि they pick out a particular particular shape, okay? Very fundamental, rudimentary, okay? एकदम fundamental shape जस्तै एकदमै simple shapes है. त्यो हरेकले के गर्छ भन्दाखेरि आफ्नो आफ्नो त्यो है, जस्तै यसले चाहिँ vertical line, your पहिलो receptor field, okay? And then likewise so this might take up like a horizontal line, right? अनि आफ्नो लिन्छ कि उनीहरूले, अनि के उले चाहिँ जस्तै यसले त्यो पिक्चरमा जुन हामीले हेरिरहेको छौँ, जहाँ जति पनि vertical linesहरू छ उले उसको काम हुन्छ त्यो पिक अप गर्ने है. अनि सेकेन्ड लेभलमा जान्छ. सेकेन्ड लेभलमा के हुन्छ भन्दाखेरि अब यो जुन फन्डामेन्टल सेप्सहरू छ नि, यो मिलेर अलिकति कम्प्लेक्स सेप्सहरू बन्यो. जस्तै यो लेभलमा के भयो, यस्तै हो, तर के छ जस्तै हैन, यस्तो यो फन्डामेन्टल सेप र फन्डामेन्टल, जस्तै यहाँ चाहिँ के छ, एउटा यो छ, तीनटा मिलेर बनेको छ. यसमा 1 2 3टा मिलेर बन्यो हैन, यसमा 1 2 है. सो त्यो जुन लेयर 1 मा भएको जुन फन्डामेन्टल जुन shape छ नि है, त्यो मिलेर a bit more complex है, a bit more complex shape, okay? अनि त्यसपछि अर्को लेयर है, अनि त्यसपछि अर्को लेयरमा चाहिँ अझै तिनीहरु अझै more complex shape है. Okay, screen is not visible. Screen देखिरहनु भएको छैन सायद गर्न के छ, are you seeing
my screen?
Subin सरले चाहिँ please share screen भन्नु भएको छ. उहाँले देखिरहनु भएको छैन जस्तो छ. So why don't you log out and log back in, so maybe you can see, because everybody else is seeing. Hey, Subin sir, please do that. Eh? Okay, all right. So now yeah, भनेपछि अनि several layers हुन्छ, अनि हरेक लेयरमा के हुन्छ भन्दाखेरि त्यो fundamental shapesहरू अनि त्यो जोडिदै अनि more and more complex shapesहरू के, अनि ultimately the full picture हुन्छ के. So that's how our brain works. र हाम्रो CNN ले जुन convolutional neural network छ हैन, so that also pretty much does the same thing, as you will see. Okay, all right. So Okay, let's go down here. Okay, okay, see, these studies of visual cortex inspired the neurorecognition introduced in 1980, right, which gradually evolved into what we now call CNN, a convolutional neural network. An important milestone was a 1998 paper by Jan LeCun. He's the AI here, Facebook AI research here, FAIR. So, this could see he's the chief. Right? Okay, he introduced something called a Linux 5 architecture. We'll look at this architecture. Right? Okay. So, and then what he did was he was able to use this to recognize handwritten digits. Okay, handwritten digits, sort of. And then he, US Postal Service, USPS, US Postal Service, okay, because US Postal Service was a big industry. I mean, it's a government entity with you. US can say it's all by mail, back in the 90s. A little bit of the electronic voice again. I mean, it was the life, life plot again. Everything was sent through mail, right? And then USPS was, it was a big organization, right? And then, okay, USPS level, and this was the banks early. What they used, they used this, the system that these guys built using CNN. They were used to, read checks, right? Or to check or read, right? Checks, check or imagine number really happens. They'll automatically read like use anything. Okay, so let's see. Now we need to dive into what is a CNN. Okay, so architecture and then how it works. So, okay, so CNN CNN, okay, first thing, let's see. Say, as I said last time, the neural network that we saw, right? This is every neuron in a particular layer is connected to every other neuron in the next layer, right? So in this lab, it's fully connected network, right? So okay, they'll have fully connected. There is CNN fully connected, all that. Right? And then so it it's okay, as you will see later, right? Okay, so it's they it uses partially connected layers, and then they use weight sharing. Weight sharing use cursor. Okay, so we'll see later. Right? Okay, so the most important building block of CNN is the convolutional layer. Like convolutional layer is the main part, main part of convolutional layer. Okay, so what is a convolutional layer? Okay, let's see. Okay, so so that you can see the whole thing. Okay, okay, convolutional layer. Convolutional layer, when you could say there's some kind of a mathematical operation which is called convolution, right? Okay, convolution value is like this. But first, I need to show you what is a convolution. Right? Convolution let me draw and show you either. So, for example, if this is your picture, right? And then you're trying to make the machine read this picture, right? Okay. So now there is something called your feature map bunch, right? Also filter, kernel filter, right? So let's say kernel, right? Kernel is sound kernel, let's see. Let me draw. Okay, so this thing, you say 28 by 28 pixel, okay? This picture, this image, and then you can have a this small kernel. I don't know how you box. So that is a kernel. Right? The kernel. Kernel could be say 3 by 3 or 5 by 5, whatever. Right? Just think 3 by 3 kernel. Right? The kernel it slices through the image. Right? You would say obviously your first stage my right? And second stage my I'll use a different color so that you can see the transition, right? Okay, second step is the 1 pixel right? And third step ma फेरि एक स्टेप यसरी स्लाइड हुँदै जान्छ कि यसरी स्लाइड हुँदै 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 यहाँ पुग्यो हैन अनि फेरि अनि यहाँबाट स्टार्ट हुन्छ है यहाँबाट तपाईँ अब त्यसमा त्यो स्ट्राइड भन्ने हुन्छ म त्यो स्ट्राइड अलिक बुझाउँला हैन त्यसपछि फेरि यहाँ जस्तै 1 पिक्सल तल गर्यो हैन लेट्स सी जस्तै अनि यहाँबाट यो माथिको पिक्सलले सिध्यायो हैन माथिको पार्ट सिध्यायो अनि त्यसपछि अनि यहाँ तल आयो है तल आयो अनि त्यसै गरी फेरि यहाँसम्म जान्छ है अनि फेरि एक स्टेपले तल आयो हैन अनि फेरि यसरी जान्छ यो त्यसरी पुरै यहाँसम्म कभर गर्छ के उसले है यो सबै कभर गर्छ है ओके सो that is called that is basically हैन त्यो स्लाइडिङ के त्यो कर्नल त्यो सानो जुन कर्नल त्यसलाई हामी कर्नल भन्छ KRNL त्यो कर्नललाई हामी स्लाइड गर्छौँ के गरेर पुरा पिक्चर हामी कभर गर्छौँ है सो द्याट इज द कन्भर्सन अपरेसन है त्यसमा चाहिँ अनि हरेकचोटि के हुन्छ भन्दाखेरि त्यो जुन कर्नल र त्यसले चाहिँ त्यो इमेजमा जुन भागले कभर गरेको हुन्छ त्यहाँको बिचमा सम काइन्ड अफ म्याथमेटिकल कम्पिटिसन हुन्छ है मेबी अ डट प्रोडक्ट or element wise multiplication, so some kind of operation है त्यो चाहिँ उसको जस्तै उसको आफ्नो आफ्नो भ्यालु हुन्छ नि त हैन जस्तै कर्नलको आफ्नै भ्यालु हुन्छ जस्तै कर्नलको कर्नलमा जस्तै यसमा जस्तै 3 जस्तै यो 2x2 कर्नल भयो हैन 2x2 कर्नल भयो अनि यसको के हुन्छ भन्दाखेरि त्यो कर्नल र तलको इमेज हुन्छ त्यसको बिचमा त त्यो सम काइन्ड अफ कनेक्सन सोच्ने के है कनेक्सन विच आर वेट्स अनि त्यहाँ बायस पनि हुन्छ वेट्स एन्ड बायसेस है अनि त्यसपछि यसले के लर्न गर्छ है इट लर्न्स the values of weights and biases right, as it moves along. Okay, all right. So this is the kernel. Right? You see kernel. You sound the same. Kernel. You see kernel. Right? It's a 2x2 kernel. Okay. And this is slide. Okay. So let's try to understand this in this picture. Right? Your picture madness. Okay. If you see here, see let's say. Yeah. Right? So if you look over here. Second, okay. All right, so you understand? You take kernel, your picture, man. This is the kernel. It could be 3x3, 5x5, whatever. Right? And this particular something, for example, then say dot product, right? For example, a dot product, right? Because that weight circle, right? And you and you dot product by the kernel, right? And you will cover gareko. Picture को जुन पिक्सल भ्यालुजहरु हुन्छ त्यो बिचमा सम काइन्ड अफ अपरेसन हुन्छ त्यसबाट एउटा नम्बर निस्किन्छ हैन त्यो नम्बर चाहिँ अर्को लेयरमा जस्तै यो कन्भल्युसन लेयर 1 मा है के भयो एउटा नम्बर भयो अथवा एउटा पिक्सल भन्यो हैन एउटा पिक्सल सो यहाँ चाहिँ जस्तै यहाँ 5x5 को पिक्सल के कर्नल छ भने यहाँबाट एउटा आउँछ है त्यसको स्लाइड गर्दाखेरि हैन उले जति कभर गरे हुन्छ नि जस्तै 5x5 को एरिया कभर गरे हुन्छ हैन त्यो र आफ्नो उसको आफ्नो भ्यालुज उसको वेट्स एन्ड बायसेस होला हैन त्यो र अनि तलको जुन के इमेज हैन इमेज उसले कभर गरेको इमेजको पार्ट है त्यो बिचको कम्पिटिसन भएर है अनि त्यहाँबाट के हुन्छ भन्दाखेरि यु गेट वन भ्यालु अफ हियर है यहाँनिर एउटा भ्यालु ठीक छ यो त स्लाइड हुँदै जाने हो हैन जस्तै यो पार्टमा के छ यहाँ अर्को भ्यालु हैन यो हैन यसबाट है ओके यसरी भनेपछि के हुने भयो normally के हुने भयो भन्दाखेरि तपाईले जस्तै इनपुट लेयर भनेको चाहिँ इमेज है इनपुट लेयर इमेज छ है त्यो इमेज भनेपछि अब कन्भल्युसन लेयर के हुने भयो भन्दाखेरि सानो हुने भयो हैन बिकज when you're sliding हैन भनेपछि यो कन्भल्युसन लेयर नर्मली है सो वी क्यान मेक इट एउटै साइजको पनि बनाउनु पर्छ प्याडिङ गरेर तर अहिलेको लागि यति बुझौँ कि हैन जस्तै यसरी इनपुट लेयरमा हामीले जब त्यो कर्नललाई स्लाइड गर्छौं कन्भल्भ गर्छौं है अनि त्यसको अनि हरेक जुन त्यो प्रोजेक्सन हुन्छ है त्यो इमेजमा है त्यो कर्नलले हैन यसरी यो टर्च लाइट देखाएको जस्तो है टर्च लाइट देखाउँदा ठ्याक्क त्यसको ठ्याक्क उसको आफ्नो फिल हुन्छ नि टर्चको त्यो लाइट जाने फिल हैन अनि त्यो पार्ट र त्यसको कर्नलको बिचमा जुन अपरेसन छ त्यसबाट एउटा नम्बर आउँछ जुन कि अर्को लेयरमा त्यो एउटा नम्बर बस्छ कि है ओके सो लाइकवाइज हेर्नुस् अनि त्यसपछि के भयो फेरि अनि यसमा फेरि अर्को कन्भल्युसन लेयर लगाइरहेको छु है यो भनेको के हो भन्दाखेरि सेम थिङ अब यसमा पनि त्यही हो हैन यसमा पनि यो कर्नल हुन्छ त्यही कर्नल स्लाइड हुन्छ अनि चाहिँ यतिको भागको जस्तै भनौँ 5x5 whatever है त्यसको चाहिँ 25 वटा पिक्सलको एक पिक्सल हुन्छ है ओके एन्ड सो अन सो नाउ अब यसमा के भयो भन्दाखेरि as we saw with the visual cortex है visual cortex मा हामीले त्यही नै हैन सो which you will see later है किनभने यो तलको लेयरहरुले एकदमै फन्डामेन्टल रुडिमेन्टरी लेभलको शेप्सहरुलाई डिटेक्ट गर्छ अनि त्योभन्दा माथिकोले अनि कम्बाइन गर्छ अनि माथि जति माथि गए त्यो सेप्सहरू कम्बाइन हुँदै मोर एन्ड मोर कम्प्लेक्स है कम्प्लेक्स इमेजेसहरू बन्दै जान्छ है कम्प्लेक्स रिप्रेजेन्टेसन्सहरू बन्दै जान्छ है Okay, so now let's move further. Okay, okay. अब यसमा के हो भने now here we can give जस्तै पहिला पहिला हामीले जस्तै के अरे क्लासिकल मसिन लर्निङमा हामीले के गर्थ्यौँ भन्दाखेरि त्यसलाई पिक्चर दिनु पर्यो भने 1D मा चाहिन्थ्यो है 1D मा दिन्छ यहाँ हेर्नुस् न all multi-layer neural networks are we have looked so far has had layers composed of a long line of neurons. That is, and the input image like flattening गर्थ्यौँ. Remember, जस्तै 8x8 को हामीले flatten गरेर 64 बनाएर पठाइदियौँ है. अब चाहिँ के भन्दाखेरि now with CNN you don't have to do that. है. अब CNN मा के हुन्छ भन्दाखेरि it can take two-dimensional input. है यो चाहिँ मैले flat गर्नु पर्दैन है. In CNN each layer is represented in 2D anyway. हैन. So which makes it easier to match neurons with their corresponding inputs. Means you don't have to flatten. You have to flatten right? So you can give a 2D input. Even 3D okay. All right, so now let's see further. So layers in zero padding. Something called zero padding. Zero padding concept here. Just the your kernels, just the red box. Red rectangle, that is a kernel, right? The kernel, okay. Okay. By the way, using 40 minutes, right? So you'll have to join back if it disconnects, right? Disconnecting it, please join back, okay? So we have about 9 minutes left on this session, okay. All right, please quickly join back. Hey, time sitting there after disconnect. Okay, anyway. So when we see now this red box, that is a kernel, right? The kernel. The kernel slide on the menu. Say you. It's the same kernel, right? Your kernel, and then your kernel, your red, blue, and then this dark blue. Right? They all are the same. Yodio, but they are different transition in time, right? Okay. Normally, so if this is your input image, just give me a second. Right? So यो चाहिँ original image भित्र सेट original image हो भने तपाईले यसरी तपाईले कन्भोल्युसन गर्दाखेरि जुन लेयर आउँछ कन्भोल्युसन लेयर 1 है C1 भनौं कन्भोल्युसन लेयर 1 ओके कन्भोल्युसन लेयर 1 मा CL1 चाहिँ हैन के हुन्छ भन्दाखेरि यसको यो चाहिँ के हुन्छ सानो हुन्छ नि त of course है you can visualize that, right? अनि त्यसले गर्दाखेरि अब if you want this CL1 to be the same size as your image, image CL1 हामीले एउटै साइजको चाहियो भने हामीले के गर्नुहुन्छ भने यतातिर हामीले एक्स्ट्रा प्याडिङ राख्दिने के है जस्तै यहाँनेर एक्स्ट्रा प्याडिङ राखेको छ है यो प्याडिङ राखेपछि हामीले के हुन्छ भन्दाखेरि त्यो हैन त्यो त अल द वे हैन यसले गर्दा के हुन्छ भन्दाखेरि हामी यो प्याडिङ यसरी राख्न सक्छौं ताकि त्यो कन्भर्सन लेयर 1 र इमेजको साइज चाहिँ एउटै होस् है दैट इज कॉल्ड जीरो त्यसलाई जीरो प्याडिङ द भ्यालु चाहिँ जीरो है यहाँ सबै त्यो पिक्सल भ्यालु चाहिँ जीरो हुन्छ है त्यसले गर्दा यसले जीरो प्याडिङ हुन्छ है Okay, so this is zero padding. Okay, all right. Okay, let's go here. Stride. Okay, let's see what is a stride. Stride the shift from one receptive field to the next. That is the receptive field. Right? It's the receptive field. It's the yanner stride. Okay, so let me see if you can guess that. Okay, it's my stride it's the same transition, I mean same receptive field or kernel receptive field. So यो यही कुरा यता ट्रान्जिसन भयो नि त ब्लू है जुन रेड छ नि रेड बक्स त्यही रेड बक्स चाहिँ ट्रान्जिसन भएर ब्लूमा गयो है त्यो कन्ट्रास्टिङ गर्नुमा मात्रै डिफरेन्ट कलर दियो हैन भनेपछि यसले एकचोटीमा होरिजन्टली कति पिक्सल गएको छ भन्नुस् त एकचोटीमा कति पिक्सल गएको छ to the right कतिले ट्रान्जिसन भएको छ हेर्नुस् न 1 पिक्सल हैन ल हेर्नुस् त यसले 1 पिक्सलले यता गएको छ नि if you see there यो पिक्सलबाट यो पिक्सलमा गएको छ नि त see so यो पोइन्ट यहाँबाट यहाँ गयो नि 1 पिक्सल so this is 1 pixel हैन x पिक्सलले मात्रै राइटमा गयो नि है डिड यु अन्डरस्ट्यान्ड द्याट पार्ट त्यो कुरा बुझ्नुभयो तपाईँहरू एक स्टेपले आई मिन एक पिक्सलले गएको छ भने बुझ्नु भयो just wanted to
Yes.
okay, great, right? So भनेपछि now that is called stride, right? This is original stride, right? भनेपछि हामी जति पिक्सलले यता से राइट ट्रान्जिसन गर्दाखेरि हैन त्यो चाहिँ horizontal है horizontally के भयो stride equal to 1 भयो त्यस्तै हामीले एकचोटीमा दुईटा पिक्सलमा पनि हामी हैन त्यो चाहिँ कति पाइला अगाडि जाने है भनेपछि जस्तै हामीले एकचोटीमा 3 पिक्सलमा पनि गर्न सकिन्छ stride 3 भयो है त्यस्तै गरी vertical stride हुन्छ vertical stride हो भने तपाई तल झर्दाखेरि कति एकचोटीमा कति स्टेप छ है एक पिक्सल पनि झर्न सक्नुहुन्छ हैन हैन 2 पिक्सल 3 पिक्सल चाहिँ तपाई 5x5 छ भने हैन 5 पिक्सलसम्म तपाई झर्न सक्नुहुन्छ है 1 देखि 5 All right, so now so that is called stride. Let's get our terms straight first, right? So we need to know, we need to familiarize ourselves with these terms. It's the yaner. See, stride. It's the yaner. Can you guess what is the stride here? Horizontal stride. Kati chesna. Understand? Exotima kati transition also. Red the two. Very good. Thank you. And it is the vertical stride. See, this one, two, right? Two. Okay, which may not be so clear here, but yeah. Okay, so okay. Our next, let's talk about filters. Right, filters. What is a filter? Okay, so neurons' weights can be represented as a small image the size of receptor field, of course. Right? So filters are convolution kernels. See, kernel or filter. Right, filter. Okay, so two possible set of weights called filters or kernels kernels. All right, so filter the kernel in a kernel right? So let's see. I'll show you a picture, right? Okay, a layer full of neurons using the same filter outputs a feature map which highlights the areas in the image that activate the filter the most, right? Okay, you do not have to define the filters manually. Okay, so here, okay, I think this will make it clear, right? Just say this is your input, right? Input is this, right? This is some kind of a Chinese architecture, right? So okay, so okay, this is your input. And I'm going to we can use one kernel, you're a kernel. That's the you. I use the kernel. Use so exactly. See, let's go bit made a horizontal white strip. White strip lines. And basically, that is a using vertical filters, right? So basically, it's something like this. Okay, so it's not. Let's try. So that you can understand in 1 second. Say, for example, let's see. So let's say maybe I can do one more here. Yeah, I think one more square bracket, like I know. Okay, so it's the happening. I'm looking on second one. Is say grayscale. Use a grayscale. Grayscale. So what we can do is, so for example, if you say black is 0, white is 1. Right? Using this is a kernel. Hey, using my red that is a kernel. The kernel. So let's call white say representation case of white is 1. Right? Black is 0. When you see, yeah, there are 1, 1, 1, 1, 1. Back is sub page zeros. Right? Okay. All right. So it's it. Right? Okay. So this is a kernel. I use a Yoda kernel, right? And orco kernel, right? So we use many kernels, right? Yoda kernel, and orco kernel, now this thing, orco kernel, say is citizens. I just make it. Yeah, 1, 1, 1, 1. So back is a page zeros, right? Zeros. It's a page zeros, right? Just like that. See white strip, right? Maybe, right? Okay. So I'm some keyboard, the Yoda kernel, right? Just say at a B, kernel A and kernel B, right? They're kernel line, right? And the kernel A will sweep through, slide through the whole image, just like we discussed, right? So your vertical filters and vertical filter and and it's slide stride on stride अनि त्यसपछि जुन स्ट्राइक डिफाइन भएको हुन्छ त्यही अनुसार चाहिँ यसो गर्दा गर्दा पुरा इमेजलाई कभर गर्छ है ओके अनि त्यो गरी के हुन्छ त्यसको जुन आउटपुट हुन्छ नि होइन हरेक त्यो प्रोजेक्सन छ नि हरेक त्यो होइन प्रोजेक्सन त्यहाँ चाहिँ म्याथमेटिकल कम्पिटिसन हुन्छ त्यसबाट एउटा नम्बर निस्किन्छ है त्यो नम्बर चाहिँ अर्को लेयरको भ्याल्यु बन्न जान्छ है यसबाट एउटा लेयर आउँछ नि त है ओके कन्भर्सन लेयर 1 है ओके त्यस्तै गरी बी है जुन होरिजोनल फिल्टर छ होरिजोनल फिल्टरबाट पनि सेम त्यस्तै है त्यसले पनि त्यस्तै स्विप गर्छ है बढाएर जस्तो होइन त्यसै स्लाइडिङ गर्छ अनि त्यसपछि त्यसबाट पनि अर्को लेयर भयो होइन ओके र त्यो छ नि तिनीहरूलाई चाहिँ हामी फिल्टर भन्छौँ कि सो जुन हामीले यहाँ माथि भन्यो नि ओके सो लेट्स सी यहाँ फिचर म्याप है त्यो फिचर त्यसले एउटा फिचर म्याप दिन्छ यसले अर्को फिचर म्याप सो वी हेभ 2 फिचर म्याप्स हियर है दुईवटा फिचर म्याप आयो होइन सो हरेक कर्नलले के गर्छ फिचर म्याप दिन्छ है फिचर म्याप मीन्स अर्को लेयर छ नि है सो द्याट इज द फिचर म्याप ओके अलराइट अब we have less than 1 minute. Let me disconnect and then please join back. Okay?